Saturday, September 23rd, 5:45 p.m. Team 1, Evan Kravitz, on the mic.
Okay, so right now I'm going to demonstrate how I'm able to detect different frequencies using Arduino and using an analog circuit. So right now I have the treasure set up to emit a 7 kilohertz signal, and you can see that when the treasure is not actually pointed at the phototransistor, the Arduino detects no frequency, as it should. So this is behaving properly right now. But now, as you see, when I actually put the treasure above the phototransistor, you can see that the serial monitor in Arduino is printing out 7 kilohertz, so it's able to detect that frequency. Okay, so now let's change the frequency to 12 kilohertz to demonstrate that it works at that frequency. And as you can see on the scope, I'm changing the frequency, and cool. It's good enough. Okay. So now, right now, treasure's pointed away, nothing's getting picked up. So now, when I point it at it, you can see 12 kilohertz is being printed on the console. So that's working properly. Okay, now finally, let's test out 17 kilohertz. High frequency. This is actually very hard to get it just right.
So what's the precision? In what range around 17 kilohertz will it detect?
I'm guessing like, I want to say 500 hertz, just because the way it works is that it locates where the bin at which it should detect the highest frequency, and it just knows that due to the sampling rate, the frequency that we tell it should detect something at, and then I give it like a 3-bin window where it should detect the highest frequency at.
Gotcha.
So now let's test it out. So now, as you can see, the 17 kilohertz signal is getting picked up by Arduino. And yeah, very few false positives, actually no false positives, very few false negatives. I think that this will be very nice on the actual robot.
Thumbs up?
Thumbs up.